Hi everyone, we're starting our second unit on functions and relations, and we are going to be looking at first chapter 14, sections A to E only. Then we will move on to chapter 7, which is on transformations, transformation geometry, and then we will go to chapter 9 and 17 with quadratics. We will then look at chapter 16, exponential and logarithmic functions. Okay, so we're going to start right now by going over by skipping through the opening problems, and we're going to start with domain, range, and mapping, and looking at relations, functions, and sequences. It's all going to be new terminology for you. Okay, so what we're going to do is we're going to start considering the relationship that's found between people's ages and their weight. If we take a look at that table off to the right, we have ages of 10, 12, 14, 16, and 18, and we have weights of 31, 36, 48, 53, and 65. Now, the relationship that exists between them, it's actually called a relation. So what we're doing is we are representing the data as a set of ordered pairs, where my values of the x are 10, 12, 14, 16, and 18, and our values of the y are 31, 36, 48, 53, and 65. Now, a relation is really a set of ordered pairs. So if I had to define what a relation was, a relation is really any set of ordered pairs. There's no special relationship between them. All we know is that as long as they are x and y coordinates, as long as they are a pair, an ordered pair, then it is a relation. Now, the things that I want you to be familiar with at this point is that our values of the x and y now, we've always called these just the x value and the y value. Okay? Now, the x value and the y value now are going to have a new name, and they're going to be called, the x coordinates are going to be called the domain, and the y coordinates are going to be called the range. So when I'm referring to the domain, I'm asking you for the x coordinates of an ordered pair, and when I'm asking for the range of a set of ordered pairs, that means I'm looking for the y values. So domain are your x values, the range are the y values. Okay, so we can describe a relation in many different ways. And one of those ways that we can describe a relation is by doing a mapping diagram. So a mapping diagram involves nothing more than designing or drawing out these two oval shapes, where one of them on the left is called the domain, or our values of the x, and our range is on the y. On the right hand side of the second oval, it'll be our range, or our y values. And what we do is we map our x values on one side, so this is referring to the previous question of the ages and weights, so that along in the x, or in the domain of the mapping diagram, in the oval in there of the mapping diagram, we have the ages, and along the in the second oval, we know that we have the range, so that 10 maps onto 31, 12 maps onto 36, 14 maps onto 48, and so forth. Now, the other thing to remember is that, of course, the domain is also called the independent variable. It means that it is free to change. Okay, so our independent variable means that it can change at any time. So that the weight, in this case, is dependent on the age of the person, because the age, we said, age was along the x-axis, and the weight, so age was along the x, and the weight was along the y. So what happens to the weight really depends on what our age is. Okay? Now, the second group of numbers, or the second set of numbers, which are the values of the range, okay, they are called the dependent variable, because what happens to the range is really going to depend on what's going on with the domain. So when my value of the domain changes, so does my value of the range. okay? So that the range is called the dependent variable. And that means that it's not free to change, and its value is really depending on another one. And that other value that it's depending on is the x value in this case. We're looking at the domain. Okay, so one way that we can describe a relation is by using a mapping diagram. Okay? Another example, or another way that we can express a relation is by actually just drawing it on the xy coordinate plane. So all I'd have to do is just say along the x-axis I put my ages of the kids, and along the y I put the weights of the kids. And in doing that I graph them, and I have more or less this diagram or this graph, okay, with these dots. And it's showing me that as the ages are increasing, so are the weights, generally speaking. Okay. The next thing that we can do is we can take a look at expressing relations by using a rule of how the domain and the range are related to each other. And the rule that we're going to use is going to be an algebraic one. So it means that we're going to use algebra or some sort of equation to describe what's going on between our x's and our y's. Okay, so what that means is basically this, okay? That if I am given, so let me just get rid of this. First of all, there was an error here. This should say the range. Okay, so what this question is basically saying is this. It says, you have an example of y equaling x plus 2, where x belongs to 0, 1, 2, 3, 4, or x is a member of, or is part of the set of 0, 1, 2, 3, 4. Remember, this term is an element of. We learned this last year, is an element of. And what that means is that our values of the domain, or our values of the x's, are actually 0, 1, 2, 3, and 4. So I know that my x values here are 0, 1, 2, 3, and 4. And when I replace those values in the equation, y is equal to x plus 2, so when I replace 0 in there, I get a corresponding value of y that's equal to 2. And if I replace in the value 1, my corresponding value of the y turns out to be 3, and then they are all increasing by 1 every time. Okay? So that the x's are my domain, and the value that comes out, once I put in my value of x, I get a corresponding value of y. So that is my range. Okay, so I could actually say that x is equal to 0, 1, 2, 3, 4, and in the equation y equals x plus 2, that means the corresponding range is going to have to be 2, 3, 4, 5, and 6. Okay, so I've shown this in a third way. As opposed to just using a mapping diagram or using a graph, I've done it algebraically now. Okay, so the next thing that we want to do is that we want to be able to read, okay, we want to be able to read off of our graphs what the actual domain and range are. Okay, and one way we do that is by using what we call set notation. Alright, now, I'm not sure whether we talked about set notation last year or not, but so I'll just give a very quick explanation of it. But set notation is basically a way of explaining what your values of the x's are, or what your values of the y are going to be, okay, in a given graph. So if I am taking a look at this graph here, okay, so if I take a look at this graph here, all right, I know that if I'm looking for the domain, the possible values of the domain, so what are my possible values of the domain? So if I'm looking at my possible values of the domain, I'm looking at remember that we're looking at our x values. So I am looking throughout my graph now, I'm going to be looking at my graph, and I'm looking horizontally at my graph to see what's happening from left to right with my graph. In other words, where are my values of the x starting and where are my values of the x ending? So working from left to right, it would seem that my values of the x are starting at -6, it appears, from here. Okay, they start at -6, and they seem to be ending at 4, as shown on my x values of my graph. So because they're starting at -6, and they're ending at -4, and because it's a closed or colored in dot, I'm including both -6 and 4, I know that my value of x has to be greater than or equal to -6, but it's got to be less than or equal to 4. Now, in using set notation, what we want to do is we want to use a very particular format. So we're going to say the domain has to equal, and we're going to open up a set of curly brackets. And we're going to say it's the set of all x, so the domain is equal to the set of all x, such that, and that's what this slash stands for, such that, and then we're going to say x belongs to the real numbers. Okay, so x belongs to R. Now, why do I say that it belongs to R? I say that it belongs to R, or the real numbers, because I have a solid line here. The red curve that I have here is a solid line. Okay? And that line is solid, meaning that every number between -6 and 4 are included. Okay? So if every number is included between -6 and 4, all right, then I'm going to put it's going to be an element of all the real numbers, because all the real numbers includes all the rational numbers, all the irrational numbers. Root 2 is an irrational number, but it sits between -6 and 4. It's approximately 1 point something. Okay? So this is the way you would actually write these out. You would write it out as the domain is equal to the set of all x. So it's read as the set of all x such that x is an element of R or basically, or belongs to R if you want, where x is greater than or equal to -6 or less than or equal or less than or equal to 4. Okay. Now, if we are looking at the range, in the range, we're going to be looking at now doing the set notation with the range. So we looked at horizontally what was going on with our x's. Now, with the range, we're going to be looking vertically to see what's happening to our y's. Where are the values of the y, or where is the range starting and where is it ending? Okay, so having said that, instead of starting now, we're going to do this in set notation. We're going to move our way from bottom up, as opposed to the domain where we went from left to right. When we're looking at range, we're going from bottom up. Okay? So that I can say, well, my range, and if I put this in set notation, my range is equal to all the set of y such that y belongs to the real numbers. And where are my values of the y starting? They seem to be starting at -2, so y has to be greater than or equal to -2, but it's going to have to be less than or equal to 3. And there, I've done my domain and range in set notation. Okay, now let's do another example here using set notation to find the domain and the range. All right, so if I use set notation to determine the domain and the range here, what I have is, I'll do this question with you right now, is that I'm looking at where my domain is starting. So let's look at the domain. The domain is my values of the x. And I say, x is such that it's a solid line, so I can say x is an element of R, such that, and we have here right here, it's such that, x is such that x is an element of R, where, now let's see what happens. Our x is starting at 0, and then it seems to be going on to infinity. So that I can just say that x has to be greater than or equal to 0, because that implies that it's going to be going on forever after 0. My value of the range, I'm looking at now, the value of the range is the set of all y, such that y is also an element of R, and we see that the value of y has to be greater than or equal to 3, because our values of the y are starting at 3 and they're going up to infinity. Notice that our values of the x are starting at 0 and they're going to infinity, even though the curve is going up, but there is always an increase. So as my graph increases this way, you understand that it's increasing along the x as well. So you see that the x is still increasing, increasing, increasing all the way. Okay. Now, I talked about set notation, and so that was one way of looking at it. Okay, set notation, x is such that x is greater than or less than something, or it's in between something. Okay, and there's a whole explanation here. We also have some other examples that we can look at. Okay, so for example, we can, let's see if I have this. Oh, I have this just as one layer. Okay, so if I look at the example here, it starts from 0, -1 to 4, 1, so that my domain is still a straight line. So x is an element of R such that, and it goes from 0 all the way to 4 for our domain, including 0 and 4. And if I am now looking at the range, okay, the range is going from -1, the range is vertically, it's going from -1 to 1. So we're looking at the maximum and minimum values vertically for the range, and we're looking for the maximum and minimum values of the x horizontally for the domain. Okay? So this is written in red. You can read that on your own again, okay, and just take a quick look at it. All right. Now, I'm going to ask you to do these two questions, okay, and you will find these in the video. So in the video now, you'll be doing these two questions. Actually, these three questions. Okay, and all I'm going to ask you to do then for homework is I'm going to be asking you to work on doing, I'm going to be asking you to work on solving for, or rather, not solving, but I will be asking you to do in class and answering exercise 16, exercise 16A, all of it. Oh, I forgot to put an A. Exercise 16A, all of it, and I want you to use set notation to answer all of those questions. Okay, and you'll have some questions to answer in the video. See you next time.